Okay, here's the calculus question. The first question says determine the length of AB in this cubic equation. Now this is very nice because we've been given the cubic formula here, 2x cubed minus 3x squared minus 12x plus 20, but they've even put it in factored form, and that's very kind because when it's in factored form like this, you are looking at the x-intercepts. If I let y equal 0, I can just read off the answers. 2 minus 2 will be 0. So one of my answers for, in fact, for B is 2 and 0. The other one, you make this equal 0 and you solve it, but the answer is always this number over this number and change the sign. 5 over 2, it's minus 5 halves. That's minus 2 and a half on the left. That's 2 on the right. The distance from A to B must be 4 and a half. 2 and a half on the left, 2 on the right. You could use the distance formula, but you'll get the same answer. Okay, determine the coordinates of T. Well, you have to know that T is a stationary or turning point. I think they might describe it in the question. What does that mean? It means that it's flat up there. If I had a tangent line, a ruler, and I put it on the curve, it'd be flat right there. We call that a turning point or stationary point, and the gradient's 0. So all we do is we take the derivative. That's the equation for finding gradients. So we go 3 times 2 is 6x squared. 2 times minus 3 is minus 6x. 1 times minus 12 is minus 12. And there's the derivative, and we make it equal 0. That's what you do every time to find turning points. We divide everything by 6, and we get x squared minus 2x minus 2. We put 2 brackets. X times x is x squared. Minus 2 times 1 is minus 2, and nicely, minus 2x plus 1x gives you that minus x. So we get 2 answers. One of them, x minus 2. Well, that's good because that's a turning point. And the other one, x equals minus 1. That's got to be the coordinate, x-coordinate of T. And how do you find a y-coordinate? You just take minus 1 and put it back into either form of the function, and you'll get 27 out. That's 5 minus, 2 times minus 1 is minus 2, plus 5 is 3. This will be minus 1 minus 2 is minus 3 squared is 9 times 3 is 27. But your calculator would give you that answer. Let's just try 11.3. Determine the coordinates of the point of inflection. Well, you have to know what to do here. The point of inflection is the place where it changes from concave down to concave up. It's a place where the gradient is decreasing, getting smaller and smaller and smaller, and then at some point in here, it starts to get bigger and bigger. How do you find it? Well, you take the derivative, but then you take it again. Take the second derivative. Go 2 times 6 is 12x. The derivative of minus 6 is just, well, you know what it is. It's just, the second derivative is just minus 6. And that's what I have here. So we want to, oops, there we go. We're trying to get that one working there because I want to take away that x there. It's not there. The derivative of minus 6x is just minus 6. And I got it right down here. It's 12x minus 6 is the second derivative. And if you want to find out where the rate of change, where the inflection point is, you make it 0. Where it's changing from concave down to concave up, where it changes concavity. That's called a inflection point. So we just add 6 and divide by 12, and we get the x-coordinate of the inflection point is 1/2. It's 1/2, so you just put in 1/2 right there, and you put 1/2 into the function. You could put it in this function, 2 times 1/2 plus 5. Well, that's 6 times 1/2 minus 2. It equals 27 over 2. You can try it. Okay, well, that's up to 11.3.